Alright, today we're doing what we're calling a bonus section for Chapter 2. Our first bonus section was 2.0, so that's where the first one came in. Today we are going to identify terms and coefficients and combine like terms. Again, this should be a review, but we need to make sure we know how to do this. Our vocab: a term is a number, a variable, or a product or quotient of numbers and variables. So some examples of what a term could look like. It could be something like 3x. Okay, that's a term. That would be considered a product of a number and a variable. Right? We don't write the multiplication sign in between them. It could just be a number, like -10. It could just be a variable, like x. It could be the quotient of numbers and variables. So it could be something like m divided by n. That's still considered one term. We could keep coming up with examples all day long. A coefficient, our next word, is the number in front of the variable. Okay, so an example would be if we were to look at 3x here. The coefficient would be the 3. 3 is what is the coefficient here. On example 1a, we are naming the coefficient. The coefficient is the number being multiplied. Tariana, what do you think the coefficient is on A? The 5 is our coefficient. Very good. Just the 5, not the x. All right, on B, Natalie, what do you think is the coefficient? -2. Wonderful. C and D get a little bit trickier. So anyone want to volunteer to guess on C what the coefficient is? Keon?
0.
Not 0. That's close. Deja? 1. There is a 1 out in front of this. If it were a 0, we wouldn't have anything written there at all because 0 times anything is 0. But there's a 1 out in front of that. So 1 is our coefficient. Alright, what about D? D, I think, is even trickier. Anybody want to raise their hand? Keon?
4.
Close. Except it's in the denominator. So for one, we know it's negative, right? Just like on the one before, what number is out in front here? A 1. So we have a -1 out there, but there's also a 4 in the denominator. So our coefficient here is actually -1/4. It's a fraction. This is what we would multiply to AB for it to come out looking like -AB/4. Alright, terms are separated by addition or subtraction signs. Separated by addition or subtraction signs. Okay, so we are asked to determine how many terms are present in each of these examples. Alright, Kelby, how many terms do you think we've got in 2A? 3, good. So if you were unsure of how to do that, I would start underlining. But every time you see an addition sign or a subtraction sign, pause. Don't underline those. So if I do that, I underlined 3 pieces. Those are the 3 terms. So if you're unsure about how to break up terms, start underlining, but pause or don't underline addition signs or subtraction signs. You can use that same method on example B. We don't really count the negative sign out in front as a subtraction sign, so I would just go ahead and underline until you start hitting addition or subtraction in the middle. Carl, how many terms do we have in part B? 4 terms. So 1, 2, 3, 4. Very good. All right. Like terms vary in their coefficient. Variables and exponents are exactly the same. Get those blanks filled in. All right, for our next set of examples, we just have to determine, are these like terms? All right, so to determine if they're like terms, we want coefficients to be different, but we want variables and exponents to match. They have to be exactly the same. On A, May, do we have like terms? Yeah. Yes, we do. The coefficients are different, but the variables and their exponents are exactly the same. What about on B? Dante, do you think those are like terms? Yes, they are. Again, the coefficients are different, but the variables and their exponents match completely. So yes, those are like terms. Adrian, what do you think about C? No, they are not like terms. They both have x's, but the exponents don't match. So the variables and their exponents have to be exactly the same. All right, and part D, Jariel, what do you think? No. On this one, we have squareds, but it doesn't belong on the n for these to be like terms, right? We would have to have the m being squared on both of them, or the n being squared on both of them. We can't mix it around. All right, on example E, Jakeem, are those like terms? Yes, they are. Same variable with the same exponent, just different coefficients. Very good. And what about F, Ellie? No, just like, what was that, letter D? Oh, actually, I don't know. I might disagree with you on this one. This one's a little tricky. These are like terms. Yep, they just switched it around. Because multiplication's commutative, I could rewrite this one as 3xy squared. Right? And then they do look exactly the same. So they do have the same variables with the same exponents. They just wrote it differently to confuse us. Tricksters. Alright, now comes the fun part. When we simplify on these, we are combining like terms. I'm going to make a note on this. That's like super, super important. We are going to operate on the coefficients only, meaning our variables and their exponents are not changing. And when I say operate, I mean things like add and subtract. Variables And exponents don't change. We're running out of room. Okay, so even though I say this, and I write it down, I capitalize it, I'll still have people tell me that they can subtract those x's and they'll end up with a whole number. Or they will add the exponents here and end up with an x to the fourth. Please don't do that. Don't be that person that makes me cry when I grade your quizzes. We only operate on the coefficients. The variables and their exponents don't change. We will deal with exponents later on this year. Right now, we're just leaving them alone. Okay, so when we go to combine like terms, we are going to operate or do 21 minus 10, but they both happen to have an x, so our answer will also have an x. Houston, what do we get? Close. On this one, I think it should be positive because the 21 is bigger and it's positive. So I would go with positive 11x. All right. Jaquan, what do you think on B? Wonderful. We add the 15 and the 7, the coefficients. We leave the variable and its exponent alone. All right, we got a lot of these examples, so let's see what's next. All right, Keon, which terms can we combine on part C?
9y squared, 13.
Good. So we can combine these two terms. What do you get when you combine those? 22 y squared. Good. That plus 3 on the end can't combine with anything, so it just comes down as part of the answer. We just leave it there. We cannot combine the 22 and the 3 because the 3 does not have a y squared. Those are not like terms. So that is our answer. We leave it alone. Nevaeh, what did you get on part D? Okay, so we know we can combine these first two terms. They're both a squared terms. So if we combine 11 minus 11, what do we get? 0. So we could write 0a squared, but that's just 0. They're just gone. They cancel each other out. So what do we have left? Just the 12a squared. So that's our answer. We couldn't combine all of them because they all have a squareds. But when we combine the first two pieces, they cancel each other out completely, make a 0. And 0 plus 12a squared is just 12a squared. On E, Lexi, what are two terms that I could combine? Okay, the 3x and the x can be combined, but I'm going to use the sign in front of the term. So when I do that, I'm going to treat it as 3x minus x. What does that give us, Lexi? 2x. Wonderful. All right. Deja, what else can get combined in that problem? The 12 and the 5. If you want, you can write it in different steps. You could bring these down and then make another step or write another line, but you don't have to. If we take 12 plus 5, what do we get? 17. Okay, remember that's a positive 12 and a positive 5, so that's why I'm adding 17. And that is my answer. 2x plus 17. I cannot combine those because they do not have the same variable with the same exponent. Alright, on F, Jamarl, what can we combine?
Me?
Yeah.
5A, 7A, 5.
Very good. We have 5A minus 7A plus 5A. So keep the signs in front. What did you get when you combined all of those?
I got, well, I'm minus the 5A and 7, so I got negative 2A.
Okay.
And then I added 5A, which got me 3A.
Very good. That's perfect.
10B.
So if we take 5 minus 7 plus 5, that ends up giving us a positive 3A. And then he said that the 10B just came down. There's nothing to combine with it. We use the sign that's in front of it, so plus 10B. That is our answer. Let's do them. Jamal, on G, what can we combine?
10x squared and negative x squared.
Very good. The 10x squared minus x squared, what did that give you?
9x squared.
Wonderful. 9x squared. Is there anything to combine with the y squared? No, there's nothing else left. So that just comes down as part of our answer. Can we combine these? No, why not? The variables are different. So just because they're both squared does not make them like terms. They have different variables. We cannot combine. We are finished with that problem. All right, on H. Jalen, what do you think?
Half plus half.
Half plus a half would give us a whole what number?
1.
1. Half plus a half gives us 1. If you take half a cup of sugar and add another half a cup of sugar, you have 1 whole cup of sugar. And then of course our variable does not change. You end up with 1x. If you want to, you could just write it as x. You don't have to put the 1 in front of it. So what we're saying here is, just like we did last week and on the quiz yesterday, instead of treating this like subtraction, we're going to change it into an addition problem. So if we change this to addition, we have to change this to the opposite. So we end up adding a positive 38m. Ooh, I left out my m. Let me squeeze it in there. There we go. So instead of subtracting a negative, we are adding a positive. Kion, what'd you get there?
Is it
22m, very good. So when we are adding with different signs, we subtract the absolute values and keep the sign of the bigger number. So 38 minus 16 is 22. 38 was bigger, it's positive, our answer is positive. Of course, we don't forget the n. On letter J, we can also change this to an addition problem. It would be adding a negative 24p. If you don't need to change it to addition to understand what's going on, you don't have to do that, but I find it helpful. Logan, what'd you get?
6th grade.
Positive or negative?
Positive.
Are you sure about that? If we add with different signs, we keep the sign of the number with the bigger value. In this case, that is Negative 24 having the bigger value, so our answer should be a negative 6p. We gotta be really careful with our signs.